Okay everybody, so I'm just going to do a little bit of recording of my experience with the Chibitronics here. I've never used Chibitronics before, but I've been reading through the sketchbook and some of the instructions and the website, and also been taking a look at some of the articles that we have for class. So as we're going through the Chibitronics sketchbook here, it's available online, which I think is pretty cool. And as we go through, we see all the different units that it goes through. It's just a tool to introduce some of the initial ideas about circuits. But it also includes a lot of creative aspects to it too, which I think is quite interesting. And definitely takes into consideration the some of the whole DIY philosophies here. Some of the instructions here as well. And one of the things that I noticed right off the bat is that the materials that are being required are actually pretty basic, and a lot of them would just be regularly available around the home, or I guess with just a little bit of searching. So what I've tried to do here is to try to take a bit of a DIY look to Chibitronics. A lot of the materials are pretty basic around the home. I do have a watch battery here, and that's what I'll be using. I do have the binder clip available here, and then actually instead of the LED stickers, what I'm going to try to do is actually use these LEDs here, these diodes here, to see if I can use them in place of the LED stickers. I know that some parts of the Chibitronics really benefit from the LED stickers, but we'll see how it goes. So all of these sheets, the whole sketchbook, is actually available to be downloaded offline, which I think off their website, which I think is great. And really in line with the maker movements and the DIY culture here and the philosophy, so I think that that's awesome. But they do make the whole booklet and the package available relatively inexpensively, but we'll see how we can do from here. So here we go. So the instructions here in terms of bending the corner, I'm going to try to tape that down and follow along here. Okay, so what we're going to do now, we're going to follow through the second piece here, tucking it under. Okay, and there we go, just mat that down. Now they've asked us to place the LED on top. Then we're going to fold this paper corner here. Okay, my first attempt here hasn't worked. Just wondering why. Probably because I didn't use a continuous strip of foil, as they had indicated here and here. Okay, let me give it another try. So one of the great things about using the sketchbook printed is if we mess up a page, here we go. Just hit print and we got a brand new one here. So we'll take our attempt number 2. Following that line here this time. You definitely become a lot more brave sticking this down the second time through. Try to stay on the lines there, Colin. The second continuous piece. Hopefully that's good. Make sure that the positive side is on top. I'm going to fold it down. Here's the moment of truth. There we go. Put that clip on. And this is definitely where the sticker LEDs would come into place a little bit better. Hold that. And then using the next page, we really get to see what that would look like, right? Just making some connections. It's nice with a little bit of a light bulb, making some connections to, you know, some things that the students would see in real world. So definitely ran into a problem trying to do it ourselves with the, without using the continuous strip of foil. Definitely ran into some problems. It's probably the adhesive from the foil I guess when it's stacked on top of each other, it doesn't really allow the electricity to flow through. So now here's my turn to be a little bit creative. So I'm not too sure what I'm going to do here. Okay, for my idea here, I'm going to turn this page around. Ooh, if I don't get too tangled here. It's my interpretation of a tree. We'll see how that works with the break in it. I've tried to problem solve that. I've tried to flip it a piece of that tape underneath so it's still the surface side to it. Hopefully that'll work. So put that right here so we can have a piece of low-hanging fruit on this tree. Just want to make sure we get a good contact, right, with that battery. So I think it's really cool because these are the type of difficulties that the students are going to run into, just like I have, and we'll see if they can try to figure it out and see what works and what doesn't work. So we'll fold it along here. And there's our LED apple tree. Not my finest artwork, but it'll do for today. I'm going to jump ahead a little bit, see if we can tackle this problem and see how it goes. It's really great. They have an explanation at the beginning of every single section and unit, so it's awesome. Really helpful for students. They can see it in really plain English. It goes through all the equipment necessary. Okay, and we'll see how we do with this one. We have a little bit more of the experience now after doing the first one, after failing and succeeding at the first one. So I know the drill here now. Put the tape down with one continuous. Although even if I don't, I've figured out how to solve that issue as well. So I know the drill here. I need to make sure I leave a gap. Okay, and this piece looks long enough to go to the end, so let's give that a try. And there we go. So we know that this gap here is connected by the LED, and that's why it lights up. But this gap over here is this contact patch closes our switch, so I guess that's like a regular light switch. It's probably easier on the book because it's a little bit smaller, is that this binder clip probably clips right to the battery, so that'll work. Fold that here. I think our connection should be good. There we go. Lights on, lights off. Lights on, lights off. So again, this is where the LED sticker would come into play and would work out much nicer than what I have here. So that's my initial introductory experience with the Chibitronics. I think this could be used, especially at the elementary level, with students that are initially learning about circuits, and also I guess part of their art curriculum as well, to really just have students come up with creative solutions to incorporate some of the technology into their artwork, to be able to have an idea and not be bound by the materials that they maybe regularly think about, but to expand their thinking, to come up with new and different solutions to add another dimension to their artwork. For me, going through this, I mean, I hit a couple of snags and issues with not using continuous pieces of foil, and then also using these LEDs as opposed to the LED stickers. I can see where the LED stickers really help students to overcome some of the technical issues that they might have otherwise using this type of LED, where the connection is tougher to get, and to really overcome that and make it more easily accessible. I think the other thing that's really nice about the way that Chibitronics is set up is that it is very open. These materials, all of this work here, is freely downloadable, and you can print it and you can use it. And I think it's under the Creative Commons licensing as well. So I think that That's really awesome, and it really breaks down a lot of the barriers that there might be for some schools that maybe can't afford to buy a kit for every student, or even just maybe students that are kids that are playing with this at home, a parent that is maybe wanting to introduce their child to this. They want to download this, they don't know much about it yet. They can really download it and try it, right? And try it out to see if it's something that their child would even enjoy without necessarily having to make the financial investment, especially if some of the material is already readily available at home. I do have a bit of understanding of basic circuits, and I definitely was able to use that here. I mean, not any more than probably your average person, but was able to sort of apply that understanding to problem solve a little bit. A student coming at this for the first time might not have that same background. They might, but they might not. And so I definitely see where if you're working in a classroom environment where you have lots of students that are working through this, you may want to initially anyways minimize some of these issues by purchasing the full booklet and the full product that Chibitronics sells, obviously assuming that funds are available. As well, though, I guess from another perspective, taking into consideration some of the ideas and philosophies within the DIY culture, wanting to make this an authentic experience in maybe a makerspace environment as well. The type of problem solving that would be needed to sort of sort through those issues with a foil and with the LED might actually serve as an additional learning opportunity for students or for adults working through this on their own. Either way, I think that this is a great product. I think that it's definitely something that touches both on the aspects of basic circuits and technology, and also stretches into the area of creativity as well, allowing students to create different designs, to take a look at problem solving some of those designs as well, to see how they can bring together both the technical challenges as well as their creative ideas. I think that, just taking a look at some of the questions that we were looking at with the articles that we've previously read both in Module 1 and Module 2, we can really see, as mentioned in a lot of the other articles, just how technology can cross over to a lot of other areas, subject areas, and a lot of other areas of interest of students. So that was my introductory experience to Chibitronics. I had a good time. Hope you enjoyed this video and you found it helpful. See you next time.